Now a function defined piecewise as sin x plus cos x to the power of cosecant x when x is between minus 90 to 0, and at x equal to 0 the function takes a value a, and from 0 to pi by 2 the function is a e power 1 by x plus e power 2 by x plus e power 3 by x by a times e power minus 2 plus 1 by x plus b times e power minus 1 plus 3 by x. And another important condition given is the function is continuous at x equal to 0. Then we need to get the values of a and b. Now if you remember, when do we say a function f of x is continuous at some point x equal to a? Provided limit extends to a plus f of x, that is the right hand limit, is equal to limit extends to a minus f of x, the left hand limit, and both of these limits is equal to the functional value at a, then we say the function is continuous. So as the function is defined piecewise here, let's calculate the limits on the left hand limit as well as right hand limit for 0. Then how will be the right hand limit at x equal to 0? So what we are going to find is limit extends to 0 plus f of x, as limit extends to 0 plus when expressed in terms of h is limit h tends to 0 f of 0 plus h. Now how is the function defined to the right side of 0? Between 0 and pi by 2. So this will be the part of the function which is defined to the right side of 0. So this would be limit h tends to 0. How will be f of h? E to the power of 1 by h plus e to the power of 2 by h plus e to the power of 3 by h by a into e to the power of minus 2 plus 1 by h plus b times e to the power of minus 1 plus 3 by h as h tends to 0. Now these are standard exponential limits. So let's express them. How do we evaluate such limits? Let's take e to the power of 3 by h from the numerator common. Then it is limit h tends to 0, e to the power of 3 by h taken common. What is left out inside? E to the power of minus 2 by h plus e to the power of minus 1 by h plus 1 by. Now denominator also, when we carry e to the power of 3 by h common, then this becomes e to the power of 3 by h times a into e to the power of minus 2 times e to the power of minus 2 by h plus b into e to the power of minus 1 times 1. Now the taken factor common gets cancelled. Now why did we create minus negative powers for e? As e is a positive number, when e power of minus infinity can be created, that means e to the power of, when we consider the limit as x tends to infinity, e to the power of minus x would become 0, right? A positive number rises to the power of, if we remember the value of the limit as limit x tends to infinity, a to the power of x value, that is, will depend on the nature of a. If a is positive, then this limit would become infinity, whereas if a is a number which lies between 0 and 1, then this number limit would tend to 0, right? Now that we got a number which is more than 0, we have created a negative term so that e to the power of minus 2 by h, as h tends to 0, would become e to the power of minus infinity. Then this, on substitution of the direct limit, would be e to the power of minus infinity. That would be 0 plus 1 by a into e to the power of minus 2 into 0 plus b into e to the power of minus 1. So this is simply e by b. Let's call this left hand limit with a value with an equation 1. Now still we need to find the, let's call this right hand limit as 1. Then we need to also evaluate the left hand limit. Then how will be the left hand limit of the function? That means we need to evaluate limit extends to 0 minus f of x. When we convert this limit to h, this becomes limit h tends to 0 f of 0 minus h. Now how is the function defined to the left side of 0? Yes, the function is sin x plus cos x whole to the power of cosecant x. So this would be limit h tends to 0. This is sin of minus h plus cos of minus h whole to the power of 1 by sine of minus h, right? By properties of trigonometric functions, this would be limit h tends to 0, cos h minus sine h raised to the power of minus 1 by sine h. Now let's convert this equation into standard form of Euler's formula. Then this is limit h tends to 0, yes, 1 plus cos h minus sine h minus 1 whole raised to the power of 1 by cos h minus sine h minus 1 into cos h minus sine h minus 1 by minus of sine h. Now why we multiplied and divided with cos h minus sine h minus 1? So that we created this function even in the power. Now when we take cos h minus sine h minus 1 as some y, then as h tends to 0, shall we say y tends to 0, right? And not only this, how will be this limit changing to? Now this limit would become limit y tends to 0, 1 plus y whole raised to the power of 1 by y, the whole thing raised to the power of limit h tends to 0, cos h minus sine h minus 1 by minus sine h. Now what is this limit now? It is purely in the form limit y tends to 0, 1 plus y whole to the power of 1 by y. This is also same as, if you remember the formula, y tends to infinity, 1 plus 1 by y whole raised to the power y, and both the limits are equal to e. Then this is e to the power of limit h tends to 0, 1 cos h minus sine h minus 1 by minus sine h. As you can see, the power is having a limit, and that limit is tending to 0 as h tends to 0. Then while applying L'Hospital rule, this becomes e to the power of limit h tends to 0, cos h derivative, that is minus sine h derivative, that is plus cos h, by derivative of sine h, that is minus cos h. Then now it is directly substitutable. Then this is limit e to the power of minus sine 0 minus cos 0, that means e to the power of minus 1 by minus 1. So how much is this? This is e to the power of 1. Let's call this limit as 2. But since f of x is given to be continuous at x equal to 0, now when is this possible? The left hand limit, that means e, must be equal to the right hand limit, that is e by b, and this both should be equal to the functional value, that is a. So if you look at a value is e and the value of b becomes 1. So what values of a and b are obtained? A is e and the value of b is 1. Let's see which of them satisfies this. The value of a is e and the value of b is 1, which is present at option A, is satisfying the given problem, right?